Good afternoon, everyone, and welcome to Improving's Virtual Lunch and Learn. Before we start, please make note of the question mark icon at the upper right corner of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send questions to our moderator. Your questions will be delivered to our presenter at the appropriate time. We are excited to present Claudio Lasala, Technical Director at Improving. He will be sharing code review. I mean no harm. Claudio.
All right, thanks, Will. Thanks everybody for joining in. Taking some time out of your lunch schedule to join us here. I always take the time to thank you. I know that I'm just a click away from you to go to Netflix or social network or something else. So I appreciate your time and attention. I'll do my best to keep you engaged. Checking out what I have to share here. So if you do need to, there we go. If you need to get a hold of me afterwards, if you have questions that we didn't get to, or if you have further things you would like to chat about, you have my contact information up there where you can find my email as well as my blog and areas of passion. Anything that you see there on my slide that you feel like, oh, he's also into guitars or riding motorcycles and stuff like that. I would like to chat to him about that. Well, just reach out. I love talking about those things. But without further ado, let's talk about this this content or go over this content. So I do get to do a lot of code review. I've been doing that, for several years now. Not just reviewing my own code, of course, but the code of the people who I work with. And when I do code reviews, I've learned to take notes about it and share those notes with the teams. Right, because that way it's not just me going in and say, oh yeah, I want you to change this and I want you to change that, but why, right? Why is it that I feel strongly about certain things, and taking the time to also coach the others around me so that we can actually learn together. Often I also blog about some of these notes. Of course, I'm not going to be blogging anything that's client specific or anything like that, but the general ideas, the general problems that I see, the recurring patterns that we see in code, that I'm always telling people, hey, we should probably clean the code up this way or that way. So today I'll share a lot of those with you. So I'll walk you over the approach that I've learned based on reading books and working with other people who also perform code reviews, and I try to get the best out of all those and see what works well for me. That's what I'm going to be sharing with you, right? Not necessarily what I'm going to share with you is going to work for you the same way, right? You're going to have to adjust to your style, to your background, and just take it from there. Hopefully you're going to be able to get a thing or two out of this. So first and foremost, it's all about people, right? You are reviewing either your own code or somebody else's code. If you're reviewing somebody else's code, you're working with people, human beings, right? So you have to learn to get to know your team, the individuals that are part of your team, right? Because together you're actually producing something. And then as we go through this presentation, you're going to see some links here. I'm going to make this presentation available as well so you can find the links afterwards. But I've started introducing some improv warm-up exercises to my Scrum teams as a way to get to learn them better, what floats their boat, so to say, what do they get excited about, how do they react to things, to enable me to better communicate with members of my team, right? So that's just something that I wanted to throw out there. Learn some of the code, right? So many times what I will do if I'm just joining maybe an ongoing project, I'll start with the nastiest thing. So I'll ask the team, hey, show me that one part of the application of the project that when you say, oh, we need to make a change to X, developers start running away or they go right? Show me that. I want to see that. Sometimes, oh, it's the invoicing module, or it's the county module. Whatever it is, that there is that one part that nobody wants to touch because it's nasty. I want to see that first, right? Because then it's okay, that's where the lower bar is as far as like the nastiest thing that I can find. And then from there, we can only get better, right? So start from that. As I do that, I will refactor the code iteratively, right? Making little changes. Sometimes what do I run into? Well, there's this one class that has a method that has 5,000 lines of code, right? So, well, that's the nastiest. That's why nobody wants to touch that. Cyclomatic complexity is like, the code metrics show a lot of problems. So let me start there. So I'll start refactoring things iteratively, and I'll document the changes. And sometimes it starts as easy as, let me just rename some variables, or actually introduce some variables for things that I'm seeing, like maybe there are some strings that are being used over and over again. Let me refactor that into one variable that has that string, and start just one step at a time, very small changes, and then extracting certain blocks of the code into separate methods or separate classes, whatever it is. But as I'm doing so, I document the changes, because again, later I want to share that with the team so that they know, they don't see just the end results, they see how did I get there, right? Because it's an ongoing process. Now, do I just go willy-nilly making changes like that? Of course not, right? So I do want to cover my code with tests to make sure that I can actually make changes and not break the way the thing actually currently works. Maybe it's already not producing the proper results and nobody knows. So what I want to make sure is that I write tests to make sure that as it is right now, I'm not breaking it, right? And again, I wrote blog posts about that, like what should we write tests for? And this is a case if you're refactoring something that's really nasty, nobody wants to touch it, and still it's something very important for the business. I cover that with tests. That's when I use code coverage to make sure that I do have a good percentage of code coverage for that code base, and I can make changes safely. As I do that, again, I will share it with the team. I'm going to take like snapshots, like showing the code diff. This is what it used to look like. This is what it looks like right now. I may share it with the team by posting it, say on Slack or Microsoft Teams, whatever the communication platform is that we use. If we have like different, like a wiki website for the project, that's where I'm going to be sharing those things with the team. Very, very important. Hear their feedback, right? It's not just, oh, hear all the amazing work that I've done here and how I cleaned up this stuff. It's hear their feedback. What do they have to say? And when you're hearing feedback, try to narrow down your focus to pay attention to their reaction. Are they going to go like, are you freaking out of your mind? Or are they going to go like, oh, this is interesting. I didn't know that you could actually do that. Gauge that. See how people react to your changes. Get a feel for their skill levels. Many times people will like overreact because maybe their skill level is just not up to par to the thing that you just introduced, right? Maybe you're like writing the most idiomatic version of the code that you can in that language, but the other folks are not at that level yet. You have to realize that. And even though, yes, that may be the best looking code ever, from the team's perspective, it's not that great, because now you're the bottleneck. Anytime somebody needs to change that code, they need to ask you to do it. So gauge that. Maybe you need to throttle down a little bit and not go as smart, as idiomatic with the use of the language, to make sure that you can actually help the team understand what's going on, right? Identify areas like that. So is it like, okay, the thing that I've introduced is up here and the team level is up here, or the team level is up here and I can easily coach them to take that extra step, all right? Or do you have to lower down that bar and help the team, increase their skills together? Also, again, always beating on this topic, figure out or understand how they react to changes, right? Are they defensive? Are they open-minded? Learn about that, right? Make sure that they are understood. Whenever they raise questions, they're not necessarily challenging your assumptions or, you know, your abilities. It's more like they're trying to be understood. So make sure that you understand them before you proceed. That's a very important aspect of it. Teach them refactoring techniques, right? So if you can read from them that they are not quite sure how you got there, well, teach them how to refactor things. If they have never done any kind of refactoring, they don't know, when you say extract variable, inline variable, extract method, you know, things like that, when you say those like refactoring techniques and they're like, well, that gives you an opportunity to teach you know, your fellow coworkers to, you know, boost their capabilities. Teach them the techniques, teach them the tools that you use for it, right? Because most likely, if you do a lot of refactoring on your own, you're probably using tools. You're not doing everything by hand. Like if you're a C# developer, for example, and you're in Visual Studio, you're probably either using the Visual Studio capabilities to extract method, extract class, or you're using a tool like ReSharper, CodeRush, whatever it is, right? Teach them those tools. I've worked with folks that they've been neglecting the use of like other tools, like refactoring tools like that, because they had not been properly coached before. That's why they would always ditch like, oh, ReSharper, no, I don't need that. I'm pretty good. And then you look at how they work, it's like, yeah, you don't really have a good command techniques. Can I show you? Allow me, please, to show you another way to tackle this. Work with the person, you know, and more often than not, you know, pretty much every time I've worked with folks over time like that, they all buy into the practices. But you cannot push your practice onto somebody. You have to understand where they're coming from, and then you coach them, bringing them your way, as opposed to just pulling the person, you know, against their will. That never flies well, okay? So let's start looking at some of the code that I've found out there. This is something that I see a lot, dense code, right? Where I look at code like this, whenever I see, make sure that my mouse is showing. Oh, there we go. Sometimes my mouse just goes away. There we go. Right? So here I see that this word is repeating on every single line. I see like a pole right in the middle, or, you know, as part of my code. That bugs me. It's a lot of repetition, right? It's one variable. Oh yeah, well, what's the big deal, Claudio? It's just one variable that's repeating. It's repeating too much, right? I don't need to read all of that, right? So again, if you're in C# world here, you can use object initializers to get rid of the repetition of that word. It's a small thing, but it's less stuff I have to see. It takes less, it shows less cognitive friction for you to understand the code that you're looking at, because there's less stuff to look at, right? Of course, this is a simple cleanup, but it also exposes something else, like, well, background back color, background back color, background for color, background for color. It's also like, well, we see a very specific pattern. It's a one-to-one object mapping here. Maybe I should use something else. Maybe I should use like AutoMapper or another library that knows how to copy properties from one object to another, right? That would be my next step on something like this. A similar example is like with, say, dictionaries, right? The same deal. We instantiate and initialize, or instantiate the dictionary, right? And then we go dictionary.add key value, dictionary.add key value, and it keeps repeating. So that block of letters, of characters there, why do we have that in there, right? Where with collection initializers, we could do away with that and just say, hey, this is the variable, this is the type, right, with the instance, and this is how I'm initializing it, right? Much cleaner. I'm only reading what's necessary for me to understand what's going on here, right? Taking that like another step into that, notice this, right? Several lines of code, and this span across way more than what we have on the screen here, but like all of this it's repetitive. It's a call to a method add key that passes in this dictionary, and then there is a string that repeats. It's the same string repeating over and over and over, right? And then this whole part here is the same, and then the only thing that's different on each line is the left 1/3 of that code, right? Very messy. Something that I've been follow quite a lot is this idea of, you know, separating what All right, I should be back now. I noticed my connection just dropped for a little bit. So separating what I need to get done from how I want to do it. So like in this, from this previous example, what did I do? Add a dictionary with the keys and the values for my API settings, right? So that's my what. And the how is down here. Well, now iterate over that dictionary and make that call to that method, passing in, you know, this other dictionary, right? That's a string that was repeating over and over. I only have it once, and pass in the key and the value that you're getting from here. It's a very simple thing, but I mean, look at the difference that it makes, right? A lot of repetitive code on the left when we really don't need it, right? Having the separation, why is it important? Well, now if I want to do something else, I want to call a different method, right? I can change it in one place, right? If I need to change this string, I only change it once. The separation also allows me to take this logic that iterates over the settings in this case and performs some sort of action. I can take that one line, move it someplace else, like a different method or a different class, and the API settings thing, that dictionary, can be coming from somewhere else. Maybe it's coming from a database call. Maybe it's coming from inversion of control containers, right, being injected during runtime based on user preferences and what have you, right? So this separation will allow you also to extend your code like that. Moving on, this is another example, very similar to it. When we lay our eyes on code like this, the brain immediately identifies, hey, there's a pattern here. There are blocks of 3 lines of code. It looks very similar. Oh yeah, XML document create element, inner text with something that comes out of another object, and then we append child. Repeat, repeat, repeat. Of course, copy paste, copy paste. Tomorrow we need another, what is this? Another credential element. Guess what? Copy 3 lines of code, paste it, and do more. Why? Right? Because doing it that way, we are forcing the reader to really read through all those lines to see if there's nothing different in those blocks. And here, the only thing that's different is, you know, what is the name of the element that we're creating, and where are we getting the value for that thing that we are trying to create here, right? So applying the same concept I just mentioned, the separating the what from the how, you know, the what is, what are the credentials? Well, these are the keys, and the values come from here, right? So I could, and here's something that I did on purpose here. I could, as I'm creating the dictionary, just read the value and push it into the dictionary, or we could do it the same way I did it here, which is with a function, right, a lambda that says, hey, whenever you actually need the value for that credential, this is how you're going to get it, right? So deferred execution, right? And then the how part, right? How do you create the elements? Same idea, it's separated. You iterate over your credentials here, and then those 3 lines, copy, paste, copy, and paste, they exist only in one block. And then again, this whole processing here from the bottom, we could move it from here into a separate little class or function or whatever you need, right, that you can test in isolation and all that. And the top part, right, that could be getting injected through dependency injection, or again, it could be coming from the database somehow, whatever. You separate the what from the how, right? Because if you want to change what you are fitting in, there's one place to go do that. If you are changing the how you are implementing that, maybe you want to change the way you create the elements, the way you append child or what have you, there's one place you're going to go and change, right? Very simplistic. The for each, if you are keeping track and you're a C# developer, you may say, oh, but the dictionary does not have the for each method. So a common practice that I've been following is I always create a for each on IEnumerable to make it available to arrays, dictionaries, anything that I can for each on. I can use this extension method for that, right? And the same example, I have a blog post that explains everything. So if you want to check that out later. Another similar thing, right? So say I have like a list of toppings, right? And I have what I call a procedural for each block, where you say for each topping in toppings, add to pizza topping. It's a lot of repetition of the word topping or toppings, right? Where add to pizza is just a method that takes in that one type and does whatever, right? I'm not big into procedural programming anymore. That's where I come from, like from 25 years ago. That's how I started programming, was with procedural languages. I rather flipping that around and calling a for each method or a function in a functional space, right? And I want to say toppings for each topping, add to pizza topping. There's still too much. I mean, one line of code as opposed to those, four, but still there's a lot of topping. You can actually go and do it like this, right? Toppings for each add to pizza. This is one of those that some C# developers may not be aware that this is a possibility, because they've been doing it like this for years, right? And maybe they've learned that they can do it this way with a lambda expression like that, but they may not know that you can drop that and use what's called a method grouping, right? Where you can just say, hey, the for each takes in a function with that signature, right? Something that takes one parameter of type topping and doesn't return anything. Hey, I have this add to pizza method that, follows that signature. So you don't have to pass that in. So it reads toppings for each add to pizza. It reads way better. But then again, the first time I've introduced something like that in a C# project, the other C# guys didn't know about that. So I took the time to actually do a little bit of training on how do lambdas work and how do method groups work in C#. Once they've learned the mechanics, it's like, yay. And then, of course, there was another guy who was a JavaScript guy who was doing something like that in JavaScript. And he said, oh, yeah, this is how we do it in JavaScript all the time. Okay, excellent. Right? So take the time to coach these things to other people. So here's a very simple code. I mean, what could be really bugging me in this code? Really, the word private there. Notice in my IDE, the way it's set up, it gives away that this is something I don't like, right? Because it's showing, hey, this is dead code. Private is the default scope modifier in C#. In good object-oriented principles, you want to keep everything private and only expose as public things that are, the public interface of the object, right? You want to keep your privates to yourself, right? Encapsulation. So why do we have the word private in there, right? When I see code like this is really what I'm seeing. I'm seeing like a trash can sitting in parts of the code as I'm trying to understand what's happening here. Why that, right? When I can just, just make it cleaner. It's a little thing, but from the eyes perspective and the mind, the less you can see it and still comprehend, right, the better. Of course, if removing the word private causes a lot of confusion because it's like, oh, I don't know what's happening, then yeah, you have to work through that. But in something like this, like if I have experienced C# developers working on the project, they all know, they should, that private is just the default, right? So something to keep in mind there. Here's another one. Again, it's a simple, couple of lines of code, right? There's a variable, there's an if that checks on this value. If it's, true, it's gonna go config, get value, this thing here, pull this value here. Else, you have to read through that whole line to make sure that there's not like an exclamation mark in somewhere that you may miss. And then, the value that you're pulling out of it. Right? For things like that, let's make sure that we use a ternary operator, right? Return, get value, we're looking at this value. If that's true, return this, otherwise return that. That's very simple, right? So whenever you have conditionals that are that simple, use the ternary operator by all means. However, there are situations where it doesn't make sense, like here, right? Where, instantiating a class and then passing parameters, and then you use the ternary like that. Remember that wall of repeated characters that I mentioned before? We're seeing that here. This is not a good place to use ternary operator, right? And it can get pretty wild. Like, look at this one, right? Instantiating multiple classes, and then you see like these blocks here. That ain't pretty, right? So for example, in this case here, like new address, you're instantiating an address, passing in the details of an existing address, right? The address line 1, 2, city, state, and what have you. So then here it's checking, hey, do we have a shipping address? If we do, you use that. Otherwise, you use, in this case, the applicant's address. We could have done away with it by creating an overload for that address method that would take another address instance. And then all this business of moving data from one object to the other, let that constructor handle. Or again, it's one of those that you could use this null coalesce operator, right? Where you say, hey, new address. You either use shipping address if you have it, otherwise you use the applicant address, right? Again, it's one of those that maybe the C# guy working on the project does not know about that operator, does not know about this way of doing things. Take the time to coach the person. Raises the question as to why is that problematic, right? The sense that it makes it harder to understand the code and start feeling confident so that you can make changes to it, right? Well, if it's a one-liner that is like clean like that, simple, there's no reason not to do it other than if people are not familiar with those ways of doing things. By the way, I have a bunch of stuff to be going over, so I will collect the questions that you guys have, and I'm going to tackle those at the end of the talk, just to make sure that I get through as many samples, examples like this as I can. Here's another one, right, on a project where I identified objects or classes named after strategy. Texas state strategy, Florida state strategy. I'm like, okay, strategy design pattern. Okay, I already have some assumptions as to what I'm going to be finding there, right? Different strategies implementing different algorithms for the specific implementations there. They are used polymorphically where necessary. So for this, I found that, yep, there's this abstract strategy class. So I'm thinking, okay, there's some common implementation for that object. And then it implements an iState strategy interface. Okay, all good. But then I get to that interface, and the interface is empty. There's nothing in there. I was really expecting to see one method, which is the method that is the polymorphic method that gets reused in places. But that was not here. So I'm like, okay, what is the strategy actually implementing? What I found that was problematic here, going to that abstract class, when we look at it, holy moly, that abstract class had like tons of methods in there, a lot of public methods in there. Why is that a problem? The problem is that if we are using an abstract class like that, and that abstract class has public methods, I can only get access to those methods by means of a reference to the abstract class. Now, but the abstract class implements an interface. If I receive an instance of that interface, right, something that implements that interface, then there's nothing I can call on that instance, right? So that violates, for those keeping tabs, the Liskov substitution principle, because that object that implements that interface is not replaceable with a parent abstraction, like in this case, an abstract class, for example, or even like the Texas state strategy. That's problematic, right? So trying to do the right thing with having an interface, having an abstract for common behavior, but then doing the wrong thing with the actual abstractions, right? Something to keep in mind. Also, in that same abstract class, I found private methods, such as the ones that we're looking at, like validation methods. Is valid email? Is valid phone? And I even wrote a blog because the next question that people ask is, well, you know, if I'm writing unit tests, how do I test the private methods? Because I mean, I'm, you know, very skilled with C#. I know that I can use reflection in my test and to call those methods through reflection. No, you don't do it. The answer to that question, how do we test private methods? We don't, right? If you're trying to reach into an object to test a private method, it's probably because that private method should be a public method in a different class, right? And so that also, of course, it can be reused, because rest assured that the is valid email functionality has got to be used someplace else, right? As opposed to just in this specific class here. So things to keep in mind. State checking. So look at this code, right? Very common. You have an if block that's checking a property in that object. And then you have an else if, else if, else if. I do not like else if or switch statements, because they all start with just like single liners or two liners or three liners, and they expand. And I always say, you know, no bad code goes without at least a switch or an if block, and many times a mix of both, right? Problems with this here is that notice that we are checking on a specific state of an object. Like in this case, the customer. Is the customer rejected? Is the customer disconnected, activated, dispatched? Those are different states, like real world states of a customer, right? So based on the state, we have a different thing that we want to execute. Now here we can also identify, well, we have the two liners and we have the three liners. The two liners are pretty much the
Yeah, it looks like we have dropped Claudio again. Just one moment while we try to get him back.
Here we go. Should be back now. My apologies for the flaky internet connection today. So here, problem with this approach is that there is a lot of repetition there. Okay, that's one thing. Another thing is I cannot just see without scrolling what else is different, you know, besides like this type of changer class that is being used based upon the state. What else is there that I'm not seeing? Well, if we look at the scroll, the horizontal scroll bar, there's still a lot more for me to see. What is the solution to that? Well, you know, of course, nowadays you just get a bigger, wider monitor. That way you get to see through the end of your screens, right? No, wrong, please, right? I have one of those monitors like right here on my side, but I don't use it to write longer lines in my code, right? That's not the point. The problem, again, also with the checking the state of an object or of like a real world type of thing model is that, you know, rest assured, like in the previous code where we had if, else if, else if, else if, I knew that in other parts of the project, I would find exactly the same thing. If this state, do this, else if this other state, do that, in multiple places. but for the different places, the implementation inside of that if was something else, right? Now, what happens if a state gets dropped? We have to remember to go remove every place else. What happens if we add a state? We have to go add to all of those different places. Madness, right? And rest assured, on this code base here, I found something like that someplace else. If rejected, if activated, if dispatched, do those things. So whenever you have situations like this, and I didn't have, unfortunately in this project, I didn't have a chance to actually provide an implementation for them, but look into the state pattern or state machine pattern, design patterns, right? Because that's what you want. It's an abstraction that represents the different states of something. And then for each state, you have a different implementation for the operations that you need related to that state, right? So if you need to add a state, all you do is create one class that implements that interface that describes that state, and then you implement whatever is specific to that one state. And then everybody can use that polymorphically across the code base. So that's something that comes up a lot. Constructor injection, where you can like pass in your dependencies. And then again, look at this, right? We know that we're injecting dependencies, and then the scroll bar, there's a lot more that we cannot see. And here, we could have just as easily, reformatted the code so that without scrolling, we can see all of the dependencies. And in this case, the reason why it was very important to see all of that was the following. It's going to lead me into the next point. Notice that, yes, great, they are all interfaces coming in, which means that like in testing scenarios, I can mock all of those things and replace them for testing purposes. But the problem was that most of those interfaces, they looked like this. They were fat interfaces. They had lots of methods in there. And looking at the body of that method, where, the class that takes in all those dependencies, it's not like it was using every single method of every single interface passed in. It was using like one method from this one method from this other one method from this other one. That is where another solid principle comes in, which is interface segregation principle. If you have one object that depends on a million others, figure out exactly what is it that it depends out of those things. Create an abstraction for that and pass in only that abstraction, right? And then someplace else, you're going to compose, where you actually go to find the implementations for that one thing, right? And then like having fat interfaces like this, where you have, just what some people refer to as like a God object or like a God abstraction, it's just too big of a bucket to drop everything in. And you end up having things like get all programs v2, and next, guess what comes next? v3, v4, e, not pretty. So find your abstractions. Like maybe in most clients, like client code, they find some clients will always look for programs details. In other, they're looking for application in the sense of like somebody filling an application for a certain service, right? Maybe they're trying to deactivate services, activate services. So identify those abstractions and create interfaces that are granular to how code clients are trying to consume those interfaces, right? So this is something that, again, comes up a lot. If you want to learn more about that, solid principles, interface segregation principle. Next, regions. It makes me shiver when I open C# code or whatever other language supports like regions, where inside of a method block, you can create a region to then collapse that block. When I see that, I know that I don't want to see that. I know that I don't want to expand that region because it's hiding ugly. Whatever it is that people condense there, I know that they are hiding ugly. It's like, sweeping things under the carpet, so to say, because like, imagine this. I open this one code file and I see this one method, get binding, where the entire method body is collapsed into a region. Do I want to open that? Do I want to expand that? Heck no, right? And sure enough, right, when I did, what do I see? E, right? I don't like what I see. I see a lot of dirty code. Is it code that could be cleaned up? By all means. I mean, very easy to identify patterns in this code that I could, easily clean up and not have this kind of like, yeah, let's hide that. Nobody wants to see that. Yeah, right? So don't use regions, right? Things like here is a very typical case of copy paste type of thing where we have some sort of like IOC registration where we say, register the iSection factory. There is this one that registered to method. There is this code, right? And then this other one, there is this code. If you keep looking at both boxes, it's going to be very hard to identify anything that's different between those two, because I don't think there is anything different. What's different is the name under which they are being registered. One is vault name, the other one is back office name. But all of this logic here, it's the same. Why don't we have that hidden away in a private method or what have you that both call, right? So whenever you identify things like that, and that's the thing that I always coach folks into, is that is bad. It's fine to do copy paste when you're figuring things out, but before you commit that as like, I'm done with the thing, look for these things and anything that strikes you as like, oh, this looks like a copy and paste that has not been well resolved. How can I clean it up? Please take the time to clean it up. Even more so when it's that simple, right? This is very simple to let it go like that. Dependency injection, right? It's great that we abstracted away a lot of dependencies where we use those dependencies, but then now we have usually this one class that provides all of the registration, and then we dump everything there, and then that class becomes a mess. So the same rules of applying abstraction, encapsulation, all of that should apply also to your like register type of class for dependencies. Find the abstractions, find the pieces that go together, right? And put them together in the same abstractions, like something to register like applicant services, something to register tenant services, something to register, whatever else. Find those groupings. Let's see, I want to move a little bit quicker through some of these, and I'm going to skip some of the slides. This is how my UI shows comments. A lot of people ask me, so how do you like comments in code? I don't. This is how it shows. My ID is set to show comments. It shows it really nasty, like red background, yellow foreground. Because if somebody has taken the time to comment something, I have to take my time to read the comments. And if the comments are meaningless, heads are gonna roll, right? Joking. So if something is like commented out, it should be out, right? Oh, what if one day we need to bring it back? That's what we use source control for, right? So don't just comment things out and leave it there. Yank it out. If you comment something like here, like pretend that this was not commented out. We're checking. Is this a duplicate person? If string equals blah, 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 throw new, blah, blah, blah. Inconclusive, this other thing. Can reverse. Duplicate address. There's always like a little comment and do the thing. A little comment, do the thing. Extract those into smaller methods or functions or whatever construct you have there, right? If blocks, they should really read like a question. That's what they are. If is duplicate address, do the same. If is eligible, do this other thing, right? Instead of looking like if array contains more than one item and this other condition and this other condition, get rid of all of that, hide that away behind a function or method that tells you what is the question that we are asking the system, right? It makes readability way better. Another example, same deal, little comment, block of code, little comment. That's all following the same idea. Here's another example from years ago. This is a Ruby on Rails project. This is a controller. And this was the change that I was reviewing for the developer, right? So look at how it reads. If current user subscriptions, if current user and not current user nil. Now here, if current user, that's using truthiness, right? If we do have an object, we are good. So why are we checking if that object is not nil? It's weird. Also, if we are concerned that current user may be null, how are we reading subscriptions out of current user? That doesn't make sense, because if it's nil here, it's going to break. It's not going to ever hit this line. And then it continues. Current testable, current subscriptions last needs payment. And then it forms this bad pattern called arrowhead, right? So when your code starts forming this arrowhead shape, take a step back, right? What is the question? Remember, we should look at these if blocks and say, what is the question being asked? Very often, you're going to find the answer right here, right? It's like, if your subscription is inactive since it requires payment. That is the question that we're asking, because that's the answer that we're giving the user. So instead of writing it that way, we should rewrite the code like this. If current user is pending payment, then tell the user about it. That's how it should read, right? So apply that regardless of the language. Same thing here, except that this was a view as opposed to a controller. If current user subscriptions any, if current user testable, if blah, 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 and then eventually cancel my subscription, right? So instead of seeing that in a UI type of element, maybe you rewrite it like this. If current user has subscription to cancel, or if user has cancelable subscription, whatever makes more sense in English, right? Makes it roll out of the tongue. That's what we're asking the system. So think about writing your code like that, right? Okay, we have, let's see just where I am with my spiel here. Let me just quickly go through what I had prepared for you. I think I can skip some of that. I do want to spend just a little bit of time here on test code. That's a typical problem. If you've heard me talk about tests and how to write tests and things like that, you may have heard that I always say test code should look just as good, if not better, than the implementation code of the feature, right? And where I see like lack of care with tests is in tests like this. Clearly, there was copy and paste involved. You look at the code, it looks very similar. It's like, yep, I have two tests. I probably have like 100% code coverage here. At that point, it doesn't matter because the tests are not really written in a clean way. When I identify and actually did the work of identifying to you like what's different in those two tests. This thing here, address type .firm, address type general delivery. That's one thing that's different. The other thing is this string that goes in there. This little bit here is different. AQF equals something, and then here it's different. So I'm like, why is that different? Why is it meaningful, right? If it was a copy and paste, why is that part of that string different? So what I did was, let me change it. Let me make it the same as the previous one, run the test and see it fail. I was hoping it was going to fail. No, it passed, right? Like, what if I put some bogus number in there, like ABC123? It still passed the test. So that's bad, right? Whatever like things we put in tests like that, make sure to make it describe why it's important. Put it in a variable that tells you why is that, what is the meaning of that value, right? So that people reading the test can actually understand what's happening there. Same thing with like tests that use, say, XML as part of the setup, like this big copy and paste. What's different? I'll tell you. The first one, address 2, doesn't have anything. In the second one, address 2 has line 2. Well, I did change it around where I removed this value from here and I've added something here. I ran both tests, they still passed. So again, even though we do have tests, it doesn't mean that we have good code or that we have good tests, because they're not really verifying what they're, I guess, supposed to. So pay extra attention to how you're writing your tests. Let me skip through these. And I may come back to some of that if we have time. Just a second. All right. Will, do we have questions? I want to make sure that we get to those before I look at more samples there.
So we only have one question at the moment, and it's to what does your iterative refactoring documentation look like?
That's a great question. Thank you very much for asking. So my documentation will look like anything I need to just convey my message. It may be me taking a screenshot of the diff, right? And then drawing arrows to the things that I'm changing. As I go through that process of like making changes to the code, I take screenshots, right? And then again, I draw boxes and arrows and I write something up like as to why is this a problem. Maybe I will link it out to maybe a blog post or a book where you can learn more about that. And then I add that to whatever the project keeps the documentation, whether it's a wiki page, whether it's like on Slack, or it doesn't have to be formal. It just has to be something that people know about, right? So that they can use as a learning tool. Besides, another thing that I use a tool called TimeSnapper. Let me show you what that looks like. Which is a little tool that I run in the background, and it keeps taking snapshots of my screen, of my desktop, every like 5 seconds or however you configure it to. So it keeps taking snapshots. So if I've gone through a work of like refactoring code, say I spent like 2 hours doing that, TimeSnapper is it's documenting the thing along the way. When I'm done with it and I want to let the team know about it, I'll just go back to TimeSnapper. I replay through it, and it's going to replay real quick, and I can like freeze, okay, this one, capture, this one, capture, this one, capture. And then I create this like step by step. Look, this is how we started. This is what I tried. It didn't work because of this. Then I tried this. That got better because of that, but I was still not satisfied because of, and then I go iteratively like that. Because again, instead of just giving the fish, you teach people how to swim. How do you get to that result? What is the thought process? How did I arrive at that kind of solution? So this is how I've been documenting. I do not write like crazy, formal waterfall type of documentation. If I just need to draw at the back of a napkin, right, and then maybe like take a photo of it and post it somewhere, this is what I'll do. Just enough to have, help the team learn. And then based on what the team learns, if it is something that's like, well, okay, this should be a little more like long-lived, that we want to keep with the project, then, if we do have certain formal documents, I'll let like the client decide, the business decide what kind of assets do we want to keep with the project. Any other question, Will?
Great, thank you. No, that was the only question so far.
Okay, sounds good. So I think we can look at maybe one of the last points here, and then I'll wrap it up. For example, one thing that I tend to see that's very dirty, data migrations, right? Where, data migrations, they have like long lines of code for the most part. You see like the horizontal scroll bar here. I cannot read the rest of the stuff. Next person comes after me to create a new migration. common. They're gonna create from a previous one. They're gonna copy what I had, paste it, and start changing it, and just maximizing that dirt. I apply also like clean code approach to data migrations as well, right? If I open a migration, I rather read it like this. What are we populating? We are populating the following tables, right? And then remember that separate the what from the how. Same thing here. For this table, this is what I want to push into the table, but I don't see the how, right? This is the what, and then I call out to something that knows how to do the how. Same thing here, right? And then at the bottom of the file, usually, okay, this is how I'm populating that into the table. Again, separating what from the how. Extremely easy to do. There's no reason not to do, right? It takes no time whatsoever, and it just sets that precedent of, try to write whatever code you're writing in the cleaner way you possibly can, because it will end up getting copied and pasted, right? That's just how we all developers work, right? We're always copying and pasting stuff and then making little changes from there. So since people are going to be doing that, try your best, whenever possible to make it clean. So just wrapping things up, keep an eye on my blog, which is lasala.net. I'll have it up again because I tend to blog a lot about these topics. 2 things here to remember. Rule number 1, do no harm, right? You are not doing code reviews and just trying to show off to people, this is how smart I am. That's not the point, right? Rule number 2, do good. Actually, you are passionate about the things that you're doing there, share that with others, coach them, right? Make sure that you understand where they're coming from and you help them, hopefully move towards, your way, if your way, you really truly believe is the best way to do it, right? And you're open-minded to also learn from the other people, by all means, right? Sometimes when I give this talk, people say, oh, do you always write great code? Heck no, I write some pretty dirty code, right? And, many times, like if I don't know the language, if I don't know the frameworks or libraries that we're using, if I have bad requirements, bad requirements will always yield bad code, period, right? If the requirements don't look good, the code's not going to look good either, right? So, but I always, as much as possible, I will look at it and say, okay, how can I make it better? How can I make it better? How can I make it better, right? Focus on, doing the best you can given the time you have available, the skills you currently have in the requirements that you were given. Again, check out my blog. If you need to reach out to me, that's my email. Keep an eye out to the improving.com virtual events so that you can hear more about events like what you've seen today. If you cannot get enough of my cool accent, check out the virtual brown bag, which happens every Thursday. I host that and I do a lot of sharing there as well. I also run a user group called Improving Code, which is about this. How can we make code better? That runs once a month, so you can keep an eye out for that as well. Other than that, thank you very much. Appreciate your attendance today.
Great. Thanks, Claudio. Thank you very much for sharing. And we'd like to thank everyone for attending Improving's virtual lunch and learn. The recording of the session will be available tomorrow from our virtual events page, which is listed right there on Claudio's slide. We hope you enjoy the rest of your afternoon. Thank you.